Good morning and welcome to today's webinar. My name is Keira Proctor and I'm the Managing Director of the Proctor Group. Today we're going to revisit the topic from one of our very first webinars nearly 10 years ago in December 2016, an introduction to vapour control layers and vapour permeable membranes. These membranes play an important role in managing the movement of moisture and air in the building envelope and help ensure predictable and robust performance. Both these subjects are themes we focus on extensively with our product ranges, an approach aligned with the latest code of practice outlined in the BS 5250 2021 standard, and the wider fabric first concept that underpins the modern approach to energy efficient construction. We'll also review the wider context around controlling air leakage and moisture movement in the UK and the relevant standards and regulations that apply. Finally, we'll consider the functions and composition of vapour-tight and vapour-permeable materials and how to manage these performance considerations to achieve a balanced and well-integrated hygrothermal envelope. Let's start with a look at the fundamental basics of moisture management in buildings. The primary driver of these interactions is the difference in temperature between the internal and external environments. The UK is described as a heating climate, which is to say the internal conditions are typically warmer than outside. As we move out through the building fabric, the temperature reduces. For buildings in cooling climates where air conditioning use is more typical than heating, for example in the Middle East, this is reversed. Today we'll focus on UK practice. The inside of the building also contains a certain amount of moisture. This comes from virtually any activity the occupants engage in. Cooking, baths, showers, even simply breathing all elevate the moisture level internally, raising the humidity. The warmer air is, the more moisture vapour it can hold, and as it cools, it loses this ability, leading to condensation forming on colder surfaces, like on a cold drink can or a car window. This moisture vapour is pushed outward through the building fabric by the vapour pressure, which is a product of the temperature and humidity differences in the system. At a certain point, called the dew point, this vapour will condense. At this point, condensation will occur, which can cause rot and mould, leading to a range of negative effects on the building fabric and even the health of the occupants. The moisture can either be driven through materials by diffusion or through air gaps by convection. To develop an effective strategy to manage the moisture risks, we need to assess how heat, air and moisture movements interact. This in turn requires a thorough assessment of the building fabric, the environmental conditions and the building uses. Once we have this, we can begin to look at optimising the materials used to reduce the level of risk, and construction membranes can play an important role in this process. Quantifying and assessing these risks requires a well-defined and structured approach, and this is detailed in the BS 5250 Code of Practice document. Since the 1970s, this guidance document has expanded to provide a detailed and effective framework for addressing moisture issues arising from all sources. BS 5250 is referenced in the building regulations across the UK and the Republic of Ireland, making its guidance universally relevant. As well as offering prescriptive advice to specifiers, BS 5250 also references appropriate calculation methods and outlines where their use is appropriate. For moisture assessment, the two methods used are BS EN ISO 13788, which is applicable to most common situations, and BS EN 15026, a more complex and comprehensive assessment for more specialised applications. Using the 13788 calculation, it's possible to model the way heat and moisture flow through the fabric of the building, and if needed, 15026 can add the effect of moisture storage and the influence of weather to the model. This allows us to predict risk and assess the drying out process, assisting in ensuring the correct specification and types of membranes for specific projects. As part of this process, construction membranes play a key role as they have clearly defined physical properties and, if installed correctly, provide a simple means of achieving the consistent performance required to match modelled predictions. BS 5250 defines this consistency in terms of as built in service or ABIS conditions and as designed theoretical or ADT conditions. To illustrate this, a construction with a predicted condensation risk when modelled would be an ADT issue, whereas condensation resulting from a leaking extract fan duct would be described as an ABIS risk. BS 5250 also defines several types of membranes relevant to moisture control. We've covered the full BS 5250 guidance in previous webinars, so today we're going to focus on two specific functions. Firstly, air and vapour control layers which are impermeable to moisture, vapour and air movement. And secondly, vapour permeable membranes, which have slightly different requirements for roof and wall applications, which can be airtight or air permeable. Let's start with AVCLs. Air and vapour control layers, or AVCLs, serve to limit the ingress of moisture into a construction. Historically, this was commonly referred to as a vapour barrier. However, the newer terminology acknowledges that such materials do not necessarily block vapour movement entirely. To see why the AVCL is important, let's go back to our dew point model. Adding the AVCL serves two functions. Firstly, by being more resistant to moisture vapour diffusion, it limits the amount of moisture that can permeate through the construction. For this to be effective, the AVCL must be on the warm side of the insulation layer, thus preventing moisture reaching the colder side. This diffusion is a substantial proportion of the theoretical, or ADT, component of the moisture risk, so by decreasing the likelihood that the temperature within the construction will reach the dew point, this risk is minimised. Secondly, by minimising the convection associated with air leakage, the AVCL reduces the possibility of air movement transporting moisture into colder parts of the construction and creating a localised condensation risk in the area. In modern buildings, convection like this can usually be attributed to as-built or ABIS issues such as unsealed joints or penetrations. Due to current air leakage requirements, most buildings are designed to be convection tight, so any air movement through the fabric is likely to be due to a defect of some sort. Dedicated AVCL membranes are typically made from polyethylene, which, at its most basic, is cheap, flexible, and provides a reasonable degree of water vapour resistance. Such membranes are, however, very easily damaged, and any tears or snags can quickly spread, leaving large gaps in the AVCL layer. They can also stretch easily, which reduces the thickness of the material and reduces its vapour resistance. Because of this, polyethylene AVCLs benefit from additional layers and reinforcement, usually in the form of a fibre scrim. 2 layers of polyethylene with reinforcement offer a significantly more durable material, less prone to stretching and elongation, while it's much harder for accidental damage to spread due to the tough reinforcement mesh. This helps to ensure the performance achieved at the design stage is matched by the final as-built result. If this is still insufficient to design out condensation risks, then adding a layer of aluminium foil to the membrane will substantially increase the level of vapour resistance. Without aluminium foil, an AVCL like our ProCheck 500 has a vapour resistance or SD value of 100 metres, which is easily able to deal with moisture loads typically found in domestic and office applications. Where moisture loads are higher, such as in swimming pools, something like our Profoil 861 with the foil core will increase the SD value to over 1700 metres, making the roof or wall construction substantially less prone to interstitial condensation. Foil membranes can also have the advantage of providing additional thermal performance from a low emissivity surface, as is the case with our Reflectitherm Plus and ProCheck A2 membranes. With an appropriate foil face, the membrane also becomes less able to absorb or emit radiant heat energy, providing additional thermal insulation. Foil face membranes may also achieve better reaction to fire results, as is the case with ProCheck A2, as the foil and glass fibre structure of that material is of limited combustibility compared to plastic-based membranes. Another type of AVCL to consider is the variable resistance membrane, such as our ProCheck Adapt. Membranes of this type have a range of vapour resistance that can alter in response to their surrounding environment. This is useful because it allows moisture vapour to move through the wall more easily when conditions allow, but still protect the building fabric when necessary. In drier summer conditions, the membrane vapour resistance will be relatively low, with an SD value of just 0.4 metres. This permits moisture to pass through a greater degree than a typical AVCL membrane, allowing the building to breathe and any excess moisture in the building fabric to dry out. When the humidity level increases, the membrane resistance increases to an SD value of 90, behaving more like a conventional AVCL and limiting moisture ingress. This helps to ensure the optimum balance of moisture movement within the building envelope, providing a healthy indoor environment whilst minimising the risk of condensation. Whichever composition of membrane is used, any AVCL is only as good as the quality of its installation and detailing. The benefits of reduced air leakage and moisture ingress will be reduced or negated if the membrane is not installed correctly. As we've discussed, using a reinforced membrane can minimise the potential for damage to the membrane, but AVCLs must still be continuous and fully sealed. To achieve this, good detailing and quality insulation are key. Firstly, all joints in the membrane must be sealed. We recommend a minimum overlap of 150 mm for both horizontal and vertical joints. The membrane should also be flat and free of wrinkles, as it will be difficult to achieve a good seal if adjacent runs of the membrane do not lie flat. Depending on the substrate, it's sometimes a good idea to use additional runs of tape to hold the membrane in place temporarily, ensuring the layers remain straight and smooth. Service runs must also be sealed, either with appropriate gaskets of air and vapour tight boxes used to prevent convection occurring in these areas, or the specification of a dedicated service void. If a foil face membrane is specified, when this service void will also allow the inclusion of the effects of the low emissivity foil surface in thermal calculations, boosting the thermal performance of the element. Lastly, floor zones and other areas where the building structure intersects the air and vapour tight layer must be considered. In these areas, it's also common for the structure to penetrate through insulation layers, leading to thermal bridging in relatively colder and more condensation-prone conditions. Products such as our Wrap-Tight FZ Floor Zone air barrier can provide a useful additional tool to link the airtight layer above and below the floor zone, while our SpaceTherm aerogel insulation can help reduce the thermal bridging effects. The other type of membrane we'll consider today are the vapor permeable membranes, sometimes referred to as breather membranes. In contrast to AVCLs, vapor permeable membranes allow the passage of moisture vapor, but are usually also resistant to liquid water. Depending on the membrane, they can also be airtight or air open. Positioned on the outside of the structure, vapor permeable membranes allow the building to release moisture whilst providing secondary protection against the weather, helping make the building structure wind and watertight as soon as possible. This not only reduces the amount of moisture that must dry out post-completion, but it may allow for interior fitting out to begin earlier by helping to provide a warmer and drier working environment. In the case of modular and off-site construction, this protection is provided during transportation and storage as well as construction itself. A durable self-adhesive vapor permeable membrane such as Wrap-Tight can even reduce the need for covering or shrink wrapping modules and panels, minimising not just panel moisture content but single-use plastic waste as well. This secondary protection can also be useful should the outer covering become damaged, such as slates or tiles being blown off a roof. In this case, the membrane can provide a temporary level of weather protection until repairs can be made to the outer roof covering. The permeability of these materials is important, as it means that protection from external moisture is provided without inhibiting the drying out of moisture from internal sources. To achieve this combination of properties, vapor permeable membranes are typically manufactured from polypropylene, the fibres of which are laid down to give a structure like a bowl of spaghetti. This has many microscopic pathways, which will restrict the passage of denser liquid water but allow the passage of vapour. In addition to this, the material incorporates hydrophobic additives, which actively repel liquid water, trapping it at the surface. A single-layer polypropylene membrane, whilst low cost and highly permeable, typically lacks the necessary water holdout to provide enhanced weather protection. To increase this, a core layer can be added between two carrier layers to provide additional water holdout. These cores may be either airtight or air open, depending on the purpose of the membrane, and we'll come back to this shortly. Similarly, a surface coating can be applied to achieve different properties. In the case of Proctor Wrap Reflect, this is a low emissivity coating as we discussed earlier, which provides a boost to the thermal performance of a wall. The fire shield membrane with a similar base fabric uses an intumescent fire-resistant coating, which expands to protect the substrates from ignition, achieving a Class B reaction to fire rating. Above this, the ProBreathe A2 membrane uses a glass fibre carrier similar to ProCheck A2, with a specialist fire-resistant coating to achieve its limited combustibility rating. Most modern buildings will include a vapor permeable membrane somewhere in their roof or wall build-ups, but which membrane is suitable for which application is not always straightforward. BS 5250 lays down some criteria for each in section 3.1.26, and these are different for wall and roof applications. In a wall, the vapour resistance must be less than an SD value of 0.12 metres, or 0.6 meganewton seconds per gram. In a roof, this requirement is lower at 0.05 metres, or 0.25 meganewton seconds per gram. Vapour permeable membranes for roof applications are also termed Type LR, or low resistance underlays. This is to differentiate them from high resistance underlays, which are non-permeable membranes like traditional bitumen roofing felt. The guidance given in BS 5250 to reduce moisture risks in roofs depends on which type of membrane is used and on the roof configuration. If an impermeable membrane, a type HR underlay, is used on a roof, then the roof must be ventilated to allow moisture to escape. This can be reduced or even eliminated if the membrane is vapour permeable, type LR. In a warm roof where the insulation follows the pitch of the roof from eaves to ridge, BS 5250 requires a 50 mm ventilated gap between the insulation and the underlay, where the underlay is type HR. If an LR underlay is used, this can be omitted and the full depth of the rafters used for insulation. This is because the moisture vapour can escape through the permeable underlay instead of via ventilation. In a cold roof where the insulation runs across the ceiling, BS 5250 requires the loft to be ventilated. The ventilated openings at eaves and ridge vary depending on the roof dimensions and can be reduced if a type R underlay is used, as shown in Table 5. A room in the roof construction with a mixture of both warm and cold roof areas is treated similarly to a cold roof, with ventilation required across both types of roof. In practice, ensuring good airflow across the entire roof volume is achieved and that this is maintained over the life of the building can be challenging. If the vents are blocked or the roof is a more complex shape, then condensation issues can easily arise. This can be remedied by simply removing the ventilation altogether and relying on the permeability of the underlay to release the moisture. However, BS 5250 does not directly address this scenario, so if this is proposed, we need to look instead at third-party certification. These certificates, for example, those issued by the BBA, allow systems and configuration outside the scope of the Code of Practice to be used. These systems are tested and approved based on their specific performance, rather than relying on the generic advice given in BS 5250. Our Proctor air membrane, which is both air and vapour permeable, is certified by the BBA for use without ventilation across all types of pitched roof. As well as simply allowing for the omission of ventilation, the certificate includes a range of recommendations and product-specific guidance, for example, allowing for use with photovoltaic roof panels or without a dedicated vapour control layer at ceiling level. Because the recommendations given in a BBA certificate relate to that specific product, it's important they're reviewed carefully. Some of these recommendations relate to the specific air permeability of Proctor air or to testing and modelling unique to that product. This means that products which rely on third-party certification for approval are not typically interchangeable, as each certificate will have different conditions for use. A lot of the specific recommendations in the Proctor Air Certificate are dependent on its air permeability. The guidance relating to photovoltaic panels, VCL requirements and the ability to remove high-level ventilation for NHBC projects are all conditional on air movement, which provides a significant additional mechanism to remove moisture. This extra boost of moisture transfer makes the formation of condensation in a cold loft space very unlikely, even under the most extreme conditions. On the other hand, there are some scenarios when an airtight membrane is more advantageous. The wrap-tight self-adhesive air barrier is also BBA certified for roofs as well as for use in walls. But it's because it's airtight as well as self-adhesive, we only recommend it for use in warm, unventilated pitched roof applications. On a warm roof, the air permeability of Proctor air has minimal impact on the moisture performance, but utilising wrap-tight instead can have a big impact on the overall air leakage rate of the building. By fitting wrap-tight on the walls and roof of the building, the two sections can easily be joined to form an airtight, vapour-permeable and weather-resistant barrier around the entire building. This is far simpler than to seal an internal air barrier, as there are far fewer penetrations, services and structural members to deal with. Reducing the air leakage rate can contribute to reducing the overall energy required for space heating. Depending on the design strategy adopted, this can give designers added flexibility, for example, allow increased glazing areas or potentially even less insulation thickness. Because wrap type makes achieving low as-built air leakage rates simpler, it's possible to use lower values at the design stage, with less scope for problems to arise, because the tested result falls short of the standard required. It's also possible to add additional insulation outside of the wrap type, for example in a facade or structural insulated panel build-up, as the wrap type will not trap moisture in the same way as a vapour-tight air barrier would. If we now look at how the entire system works, in this case a wall, we can see each type of membrane has primary and secondary roles to play. Internally, the AVCL minimises condensation risk by limiting the ingress of vapour from the internal environment. Externally, the vapour permeable membrane prevents the ingress of moisture from external sources, whilst ensuring internal moisture can escape. In addition to this, both membranes may also contribute to limiting air movement, increasing thermal insulation, or providing additional fire resistance, depending on the specific composition of the product. This combination of functions allows a versatile and flexible approach to the design of the building envelope, with the properties of the basic fabric supplemented and supported by the membranes as required. We have a range of webinars and CPDs available that go into much more detail about these functions and interactions, so please get in touch if there's any aspect you'd like to hear about in more detail, and we can point you in the right direction. We'll now move on to our Q&A.
Good morning, everyone. Welcome to our first webinar of 2026. I hope you're all doing well, and thank you so much for joining us. With almost 250,000 views of our webinars to date, we hope to continue to grow. So please keep plugging in and joining us. So as you know, for those of you that have been before, we will stay as long as we can to answer all your questions. We already have quite a few coming through on email and on the YouTube feed, but you can ask them here on YouTube, email webinar@proctorgroup.com, or direct message us on our social media channels at Proctor Group. Similarly, if you want to request a product sample pack containing the materials or information discussed in this webinar, or book a meeting with one of our staff, you can do all that on our webinar page, which is www.proctorgroup.com/webinar. So please feel free to reach out. And that is where you will also find your personalised CPD certification on that same link there. If you've registered, you'll receive a follow-up email with all of these links and a link to the replay. Late registration is still open for this week's webinar if you want to get hold of that replay link, and you can then circulate it to others within your businesses if you like. It does really help us out if you give us a thumbs up and subscribe to our channel to see what's coming next. So just to introduce the panel for our live Q&A, we have some familiar faces and a newcomer. So newcomers first, our Business Development Manager, Nick Backhouse. Morning, Nick.
Good morning, Keira. How are you doing?
Good, not bad, thank you. Senior Technical Advisor, Pamela Howitt. Hi, Pam.
Morning, everyone. Hi, Keira.
Our Technical Regional Sales Manager, Linda Kay.
Morning, Keira. Good morning, everyone.
Morning. And Adam Salt, our Head of Global Sales. Morning, Adam.
Morning, Keira. Morning, everyone.
Good. So I'm just going to jump right in with the questions here. So if I can just come to the YouTube feed first, please. So Paul has asked, why is air leakage such a concern in buildings? And let me just figure out who to direct this one to. Who wants to go first? Any volunteers?
I don't mind.
Perfect. Go for it, Nick. Thank you.
Okay, good question. So I suppose air leakage is really important point to raise. As we know, Part L of the building regulations in England and Wales requires strict air tightness. So air leakage causes uncontrolled energy and heat loss, which obviously reduces the thermal performance within the buildings. As you can imagine, cold air coming in from the inside and warm air leaking out of the building. As a result, it can cause also interstitial condensation within the structure. I suppose an example could be if the building's residential. If you're designing a residential building, will the rooms will be really cold in winter. This can increase heating bills and carbon emissions. Carbon emissions, which, as we know in Part L, we need to reduce. The warm air will continue to escape, and that's obviously with the heating. Unless you live in Yorkshire, then you can just put a thick jumper and a hat on. But I suppose a simple way of addressing air leakage, I work with a lot of architects in the north, and would be to use a membrane like our Raptite, which is self-adhesive. It's also airtight and vapor permeable.
Super, thank you, Nick. Pam, if I can come to you for Paul's next question, please. What's the risk of placing a vapor control layer in the wrong position? Another great question.
Yeah, absolutely. So the big problem with vapor control layers is that they're vapor tight. So or degrees of vapor tightness. So that means that they are going to prevent vapor passing through. Now that's great when it's on the inside and you can encourage that vapor to stay within the room space and to be ventilated out through trickle vents, open windows, extract fans. If you allow a lot of that vapor to get further into the building fabric before it hits that lesser permeable or impermeable layer, you can get a point where the vapor can't continue to transfer out. So in the UK, we're a heating climate. Our vapor drive generally from inside to out most of the year. And by having something impermeable externally, you can actually stop that vapor being able to dry out, where you will then get moisture loading. Could be a dew point, could just be saturation from humidity and vapor passing through, and that's going to lead to degradation of your wall structure essentially. So it's kind of really important to make sure you get it on the right side.
Okay, thank you very much, Pam. Appreciate that. Linda, Marina, I'm just going to keep going through YouTube, and then I do have, I think about 6 or 7 now via email as well, so I'm coming to them all. Marina Phillips has asked, how do membranes contribute to compliance with UK building regs?
So when you're looking at the compliance, the main function of the membrane is where you're actually going to use it. Well, so what type are you going to use from that to begin with? And then you have to think about what the membrane is going to do. So is it going to be on the outside protecting it from protecting the rain from getting through into the building? During the construction phase, this is why a lot of membranes are used on the outside. And then is it going to be from preventing wind-driven rain for basically during the facade for the lifetime of its building, for the building? So you've got to control the movement of the vapour or how to allow the building to dry out depending on what membrane you're using and where. When you're looking at air tightness, it can actually help achieve things like your SAP or your BER target. So they actually, membranes play a crucial part, if you like, in ensuring buildings compliance in the UK, particularly in terms of energy efficiency now. So the UK has introduced Technical Document Part L, which provides guidance on basically energy efficiency for buildings, but you also have like Assist Part C or Approved Document C, which is more commonly known for, of the building regulations, which actually provides assistance and detailed guidance on moisture in building construction. So it looks at things like damp proofing, it looks like ventilation rates, and basically protecting the building fabric from water ingress. So other documents that you can look at, as we spoke about in the webinar, is the BS 5250 2021. It gives really good guidance on best practice to prevent moisture issues within buildings. So a lot of good guidance out there that we have to comply with.
Absolutely. Thank you very much. A lot of chat about Part L already today. We should maybe think about a webinar on that itself. It's quite a good topic. Adam, Greg Robertson has asked, what is meant by fabric first design? You take that one?
Yeah, that's such a good question for me as I've just finished with my own house. And one thing I was keen to get was an air source heat pump and move to more renewable energy performance from a heating system. But a fabric first design is those renewable energy technologies and heating systems, they only work effectively for your building if you've got good fabric first design. So that's looking at the insulation or thermal performance and mainly the air tightness of your building. But you could also consider thermal bridging as well. And the idea is to kind of reduce that energy demand to make sure those systems run efficiently. So when you're retrofitting a project or even going for a new build process, look at the fabric first with your insulation levels, your thermal bridging, and air tightness before you look at all those fancy sort of mechanical systems, because then they'll run more efficiently when you install them as well.
Great point. Did you go for an air source heat pump?
I did,
You
yes,
did.
yeah,
Oh, interesting.
yeah. If anyone's got any questions, I'll happily answer them.
Good to know. Okay, Pam. Paul Hadfield has asked, do the coatings on your membranes contain PFAS, so-called forever chemicals?
Yes, so it's a really good question. And these are chemicals that are basically in everything that we use, from packaging to cosmetics to cookware, as well as building fabrics. It it is the case that we cannot say at this moment in time that our products are PFAS free. Just by the very nature of what building fabrics and construction materials and membranes have to do, especially ones that are permeable, they do quite often need assistance from additives to achieve those performances. But please be rest assured that they are obviously kept as much of a minimum as we can, but also that we are actively always looking and researching alternatives that we can bring into the technology so that you get the same high performance from the products, and we can look at making them um, more stable, more I don't know if sustainable is the right word to use with them, but certainly taking out these reliances and some of these chemicals that, can and have been proven to have some problems. So I think there is a definite move towards that in the construction industry, taking that away. I don't think it's moving as fast as other areas, but it's certainly an area that we are very, very strongly aware of and looking at alternatives.
Yeah, there's quite a number of research projects ongoing, isn't there?
Absolutely.
As you say, whereas we're not alone in terms of the membranes that use these
Yeah.
types of additives.
And we've invested
Okay.
quite heavily, sorry, but I was just going to say
Mm,
we've invested quite heavily so far in our own internal research projects as well. So, we're definitely taking it very seriously.
yeah, good. And Pam, if I can just stick with you as well for this one. So when using Proctor Air over existing rafters, this is from Mark, where previous membrane was a bituminous felt, can it affect the performance of the Proctor Air membrane due to contamination of the rafters?
If there is a lot of the breakdown of bitumen left on the top of the rafters, then yes, bitumen itself acts as a surfactant on membranes. So you may get some you may get a reaction which might manifest itself during the sort of the reslating phase, which is one of the reasons why certainly with re-roofs we do strongly recommend that if you know there's going to be heavy rain at the time, which seems to have been the last 2 or 3 months up here, constantly raining, that really it's good practice to use a temporary protection just during that phase, where you've got occupants below. Obviously, there's things that you can do by making sure that you clean off that residue as much as possible and keep your exposure time to limit. When it's actually in covered by the slates, it's not a problem at all long term with that.
Okay, good. And last but not least, Pam, and I'm going to go to everyone else. This is one that came through from email, but I noticed he's just put it on the feed as well. So just in case it's
Okay.
disappearing somewhere. From James, when insulation is fitted between the rafters to create a warm roof, how is ventilation to either side of the breathable membrane managed? So, i.e., can the membrane lie flat on the insulation, or is there a need for counterbattens?
Yeah, so it's very much dependent on the type of membrane that you're using. But if we take, for example, Proctor Air, that product can be fully supported on your insulation. So you don't need to have a ventilated gap or a void below the Proctor Air. So that can be beneficial because it means that you can enhance the amount of insulation that you can accommodate between your rafters. Um, but obviously, if it's fully supported, you do either need to then use a counter batten above it before your tiling batten, or you can put your counter batten on first and drape your membrane. Um, we have no preference. Both work. There's maybe a marginal benefit to not having an air void where cold air could accumulate, but we actually find it tends to be a geographical preference. So roofers up here have no problems laying membranes directly on a supported surface, whereas the further south we go, the preference can sometimes be counterbatting first and drape it.
Good, thank you very much. Linda, I'm going to come to you next with some email ones so people don't think they've been forgotten. But in the meantime, I've lost track of Franco has said yes, but why do we need trickle ventilation then? I'm not sure if that was in reference to another question we've answered. I didn't quite see when that was posted. So if you can clarify what that question was in relation to Franco Semeco 7021, that would be really helpful. Linda, okay, Craig has asked, looking at doing a project which will make it highly insulated, a highly insulated building, not using a vapor control layer. Is that correct? You're on mute, Linda. You need to unmute, Linda. There's always one. It's like going back to COVID days, isn't it? Oh, and you need to unmute again.
Yeah.
There we
Is
go.
that us now?
That's it. Go for it. Go for it.
Sorry.
You're fine.
I'm just having one of those days, I think. So when we're looking at projects with highly insulated buildings, it's one situation where a vapor control layer is probably best to be used. As what it's going to do is going to prevent that vapor from the inside from entering the insulation, if you like, because what could happen, it could enter that insulation and potentially sort of reach the dew point at colder interstitial surfaces. So it's one where it's best used, but often the risk is higher if you're looking at a well-insulated wall and roof, as there's no leakage there of heat into the construction. So it's like depending on the use, the type of placement of your insulation, it might not be critical, but it does include a number of benefits. So we're looking at things like vapor control and air tightness would certainly be beneficial. But depending on the construction, you may also need to use a vapor permeable membrane, or what you call a breather membrane, if you like. So these are important in sort of buildings like timber frame, SFS, SIP, and what we call mass timber buildings. So this is like CLT. What we would say with these one is we would sort of recommend doing some sort of condensation risk analysis like the Glazier method, which is pretty standard. Most people would use it, but if you were looking like a solid wall construction, for example, you might need to do something more in depth in a condensation risk analysis. So what we call this is called WIFI, which looks at the hygrothermal functions and the reactions within the wall. But that's something that it's someone who's trained in working with WIFI. So feel free to contact us. We have people that are trained with how WIFI works and what would be required from that.
Thank you, Linda. Nick, Sarah has asked, what does vapor permeability actually mean?
Yeah, okay. I'll jump on this one. So, yeah, okay, vapor permeability, I suppose, in a simple form, when talking about membranes, I suppose really it's the capacity to allow the water vapor to pass through the membrane from the inside of the building. A product like our Wrap-Tite. Ultimately, this prevents moisture and condensation build up within the building. Vapor permeability, high permeability allows rapid moisture to escape from the building, whereas a low permeability can act as a vapor barrier. So I suppose following on from some of the conversations this morning, it's really, really important to think about the building use at a really early design stage. Will it be residential, high occupancy? Will there be a high level of vapor, from the cooking, showers, and residents in general? So I think it's really important to understand, what you actually want from your membranes. And like Linda's just said, I'd definitely encourage the listeners, viewers, and the architects to reach out and discuss, maybe with one of our specification or technical team, who again can run the moisture calcs. This can this can assist and offer support on the projects and the design.
Yeah, perfect. I see that Franco's come back and clarified on that question. So if you need air tightness, why use trickle ventilation? So maybe Pam can help with this one as well, but I think it really comes down to what your strategy is for that building. So if I take my home, for example, it was built to Passive House principles. It's not Passive House certified, but it has extremely low air tightness. So we have MVHR, so mechanical ventilation heat recovery systems within our home. A lot of commercial buildings or low airtight buildings will have these, and essentially we have no trickle vents. So that's bringing in the fresh air, but the whole idea is it's controlled, so you don't have air leakage when you have a very airtight structure. Pam, do you want to add to that answer? Or maybe Adam was going to say something, sorry.
I was, but you've kind of taken the words out of my mouth there. But yeah, it's
So
air leakage is looking at kind of eliminating uncontrolled air. So the cracks and penetrations for your building where air can escape, the warm air and the cold air coming in. Fresh air or is still essential to your design. So preventing that, allowing that moisture to escape from the building, having the correct ventilation systems. So in big commercial buildings or passive house designs, you will have those mechanical systems. But in domestic, we tend to see trickle vents to provide that sort of ventilation. Anything else, Pam?
No, I think the both of you covered it admirably, but yeah, I mean it's just that there's less focus in the UK, I think, in domestic large scale developments of using either MVHR, a decentralized extract, and that's something that we're maybe lagging behind Europe in. We've been going to trade shows for years and they don't understand why we don't use this type of technology, because it's second nature to them. So until we adopt that on a larger scale, we're with trickle vents. But I think with the energy targets we have to hit, it's not going to be long before trickle vents are going to be, a thing of the past.
yeah.
I think it comes down to a lot of the house builders with the challenges of installing ductwork, and also having that in the building is quite new for us in the UK, especially as homeowners. So in America and in Europe, that's quite a common sight to see in buildings.
Mm.
But I think that will change. But also, there's a good area for innovation in that sector, away from ductworks, to try and help with those pressures.
And
I
there's
think it's
cost. Sorry, go ahead, Pam.
Yeah, no, I was going to say you're right, the cost there, but I think also it's worth noting that there are passive options that will provide this same level of house ventilation. So you're not stuck with something that might need a lot of maintenance, like additional yearly maintenance, which I think is what concerns a lot of people. It's something else to go wrong, whereas actually it shouldn't be.
Agree. And I think as well that the reason why we probably see it going this way is because at the moment we're almost entirely relying upon the occupants having that education to know when these vents should be opened, and again, in terms of air leakage and energy efficiency, that's the biggest factor in energy costs and air, energy loss from a property. And if the individuals aren't interested or educated in how to manage that kind of condensation and air strategy, then it's a risk. So I think we were seeing it coming. There's definitely building to lower air tightness, and certainly in Scotland, we're kind of carving the way in certainly the commercial sector with some of the school buildings, etc. So I hope that answered your question about air tightness and trickle vents. So I think the jury's out on it. Really? Adam, if I can come back to you, please. Again, this is a question from Anthony via email, which kind of covers what we've been going over, but maybe to have something to add to it. So what role does air tightness play in moisture control?
Okay, that's a good question. So I suppose if we think about air leakage in a building, it's going to be areas where that cold air can come in, and likely then that warm moisture air is going to find those cold spots to condense on. Quite commonly, we see this around windows, especially in older buildings when they insulate the building, and same way with adding air tightness. So it becomes kind of hand in hand, air tightness and moisture control, when you're looking at the design. But yeah, I think it's preventing those colder spaces occurring in your building for that moisture to condense on there really. I feel like
Good.
Pam's going to add something there. No, all right.
No, Pam speaks far too much. I always ask Pam too many questions on this because she's just a fountain of
She's,
knowledge.
she's
So
very good.
speaking of which, we'll pick on Linda next, who's also a fountain of knowledge. So Jill has said, I'm getting confused by types of membranes. Can you explain again what are SD values? How should specifiers interpret them?
You and me both, Jill, get confused with that sometimes. So the diffusion resistance or SD value basically indicates how strongly a material resists the passage of water vapour. So it's given in meters, if you like, and it describes the air layer thickness that offers the same resistance to the water vapour diffusion. So when we're talking about a low SD value, we're looking at things that can basically that moisture can diffuse more easily through the material. So these are what we would call vapor permeable membranes or breather membranes. So their SD value, if you like, is less than 0.25 meters. So when you go into things that are higher SD values, we're then looking at products like vapor control layers or AVCLs, if you like. So it's kind of getting, when you're using membranes, you should really be looking at the whole type of construction of the building. So for instance, if it's timber frame or SFS, what it's actually going to be used for. So if it's going to be an office building, people are not going to be there all day, whereas if it's student accommodation, it's going to be a lot more people. And then basically the full build up, where it is and how all these layers are going to interact with each other. So it's not complex, but you just have to take things into consideration. I don't know if anybody wants to add to that.
No, I was just going to say it can almost sound more confusing because ironically, the lower the SD value, the better the vapor permeability. So it's
Yes.
almost like, so the lower figure they have when you're looking at SDs, the better. The higher the SD, the lower the vapor permeability. So it almost seems a bit back different for me, but that's just how it's done. So.
I think it is quite confusing because a lot of people think the same as you and I, Keira, that that's the way it should be, but it's the way it is.
But you
I, s-
explained it well with the meters there.
I
Thank you.
suppose from an export point of view, it's worth
Mm.
considering membranes, especially that come from abroad, and looking at that value, the SD values, because what might be classed as a breather membrane in another country will not technically be sufficient for a breather membrane in UK climates and conditions, which is why the BS 5250 outlines really good guidance on the SD value for a breather membrane. So
I think
worth
that's a
talking.
great point, Adam. And I'm actually seeing products coming in from Europe, which we know doesn't meet the roof or wall regulations, SD value wise, specifically more in the walls, which is well, the roof, to be fair, would be as concerning. But yeah, we're seeing these products coming in and starting to be used. So I think it's really important that people understand that products should be meeting the BS 5250, which is
Especially
0.12 for walls and 0.05 for roofs.
Yeah, we see it especially in like the facade sector, where they're looking at maybe fire performance materials, which is kind of the drive going forward, and rightly so. But there's also taking that holistic approach of also looking at the vapor permeability performance and how that affects your building, not taking it all into consideration, not just one sector.
Great point. Okay, Nick, haven't spoken to you for a little while. A nice one for you. So Harry has asked, what is interstitial condensation?
Okay. Interstitial condensation. Great question. We've discussed this. We've touched on this in the webinar already. Ultimately, it's moisture. It's moisture forming within the structure. So it's caused by the warm air reaching cold surfaces ultimately in the building structure and the cavities. Unfortunately, with the condensation, it remains completely hidden and undetected. And as you know, with the condensation, can end up with damp, mold, or I suppose even rot over a period of time. Not ideally perfect for the building or residents, to be honest with you. I work with a lot of architects in the north of England, and I'll say this is something that can be, I suppose, easily designed out at an early stage with the architects during specification stage. So I suppose for the architects listening today, by working with people like membrane specialists such as ourselves, if you send us the through wall build up, we've got a brilliant technical team. We can run calculations, we can show the U values, help you out with the moisture risk analysis, and I suppose to combat the interstitial condensation issue, we can help specify the correct membranes and VCLs.
Absolutely. If in doubt, just send it across. We have people doing these
Yes.
calcs all day,
Yeah.
so please do. Right, Pam, I'm going to come on to some very technical questions sent through via email from Julio or Julio Hernandez. So there's 4 here, so I'll just ask them one by one.
Okay.
Proctor Air's BBA certificate relies heavily on modelling and simulation. What long-term in situ performance data do you have from completed developments?
Okay. I'm assuming, because the only thing I can think of that we've got mentioned in our Coldrift BBA regarding simulation is regarding our recent addition of the PV panel clause, and that was related to the NHBC introducing rules a couple of years ago where they wanted to see additional ventilation below the areas where inline and PV panels were being used. So we did, to back up a lot of our experience on sites up to this point, we did that testing to sort of back it up so that we could present that to the BBA. They assessed it, deemed it to be appropriate, and allowed us to include that in our BBA certificate. In terms of other physical functionality of the membrane, that's based on testing to BSEN 13859-1, which is for the roofing underlays. And we've been developing, promoting, marketing, and working with air permeable, low resistance underlays for over 25 years now, probably getting on close to 30 to be fair. So we have a lot of real life understanding, monitoring from years ago when they came out, things like the partners in innovation. So it is very much backed up with a long life of on-site as well as auto-generated or computer simulated. You've got to start somewhere, and yeah, we wouldn't be publishing things that we didn't believe was the case.
Absolutely. Okay, question 2. The BBA certificate, again for Proctor Air, assumes a well-sealed ceiling. In your experience, how consistently is this achieved on volume housing building sites?
It's an absolutely great question. The requirement for well-sealed ceilings has been around now for well in excess of 15, 16 years since it was included. In fact, probably longer now as well. I kind of lose track of time quite often. So, I think designers from drawing board are aware of the need for well-sealed ceilings. Now, I should sort of quantify this by saying that Proctor Air is an air permeable underlays are much more capable of coping with the additional moisture load that comes with a poorly sealed ceiling than other types of membranes. This is kind of why NHBC said that if you're using an airtight membrane, put in 5 mil ridge ventilation. So we would hope that with today's quality control that should be carried on with the golden thread on site, etc., that actually well-sealed ceilings are becoming more of the norm than even what they were 10 or 15 years ago. One way to do it is include your vapor control layer. It doesn't have to be a high spec one, it can be quite a low resistance one, but it's just another mechanism for controlling that. It's again, why you can't look at things in isolation. It has to be looked at holistically.
But it comes on quite nicely to the next question. So if that ceiling air tightness is compromised, what's the failure mechanism? So what he's asking is gradual moisture buildup or rapid interstitial condensation.
Yeah, again, it depends on the degree of that area that's compromised. Obviously, if it is a recessed light fitting that's come out right above your shower, and you've got a family of five that are having showers constantly, that's going to be quite a rapid failure. If it is just that you've got cracks in your joints, or maybe your attic's not terribly well, attic loft hatch isn't well sealed, that's a more gradual one. What you might see is probably nothing that would be, it's probably not going to be something like you're going to get moisture condensing and then dripping into the building. But where we see it, or where we get alerted to it, is at Christmas time when people go up into their loft to bring down their decorations in their Christmas tree, and they see areas where there's extra moisture in that roof space because it's colder. There's extra moisture going up there. Um, you might see mildew and things like that on your um, suitcases if you store them in your loft space. And that could be from a leak from inside. It could even be something as simple as if you've got ventilation coming in, that particular thing is bringing a lot of too much air into the loft space. So there's a lot of reasons. It's not necessarily down to one thing, but the big thing is you're basically going to have areas perhaps at the tops of your cavity walls, if they're not being closed off, where there's excessive moisture signs. And it's likely to be more subtle than
Then
Niagara
rapid.
Falls.
Yeah. Yeah. Okay, last question from Mr. Hernandez. Does your test method for Proctor Air only consider the roof build-up, so the layers that the roof is made up of, or does it also include influencing factors such as the pitch of the roof, location of the roof, i.e., is it in a location, a coastal location with very severe exposure, etc.?
I'm not entirely sure under what aspects all this is relating to, but obviously a lot of our testing, like our wind uplift testing, allows you to use the membrane without laps, taped laps or sealed laps, or reduction in batten gauge, sort of zones 1 to 4. So that takes into account the location. Obviously, things like coastal locations relates to water resistance, etc. Exposure again, W1, water holdout. Um, a lot of the stuff that we have to test and know about Proctor Air relates more to the fixings and the type of outer covering. Membranes are secondary protection, they're not primary protection in any way, shape, or form. So, you do need to make sure that your outer covering, be it your facade or your roof covering, is right for the situation. And then you back that up with a high quality membrane that can cope with all the other aspects of it as well.
Okay, super. Thank you very much, Pam. That was a bit of a long stint for you there. Adam, Paul has asked on the YouTube feed regarding a room in the roof construction and the use of an HR or LR underlay to the roof. Is it dependent on their type of roof covering, and are they considered, if they're considered a tight fitting roof covering and does not allow any ventilation at the void at roof batten detail? So for a room in the roof construction.
Yeah, so in answer, yes, it kind of does matter on your outer roof covering. I think if you're using, say, fiber cement slates with uh, an LR membrane, you probably want to be looking at sort of counter batten design to allow that airflow through. Um, so yeah, I think you've got slates, tiles, and concrete that all allow air to pass through and offer that sort of ventilation at that membrane stage, which is good. The tight fitting ones, maybe fiber cements or even like a metal roof, you have to consider then some ventilation to counteract that without that airflow coming through.
Okay, good. Thank you very much. Nick, and we're coming on to sort of our last 5 questions or so, which is good, on the home straight for you guys. Brian Greer has asked, what is the difference between a vapor control layer and a vapor permeable membrane? So I know we've been talking about this, but it's good just to go back over if it's wanting
Yeah,
clarification.
okay. Yeah, we've been discussing this also, but I think ultimately vapor control layers installed inside the building on the warm side of the insulation. Ultimately, their purpose is to control the amount of moisture passing through into the building structure. As we know, this would cause moisture within the cavities and the structure from discussions earlier. I suppose that there's lots of different types of VCLs available. It's really important to understand the difference between them and what you actually need for the building design. Do you need a fire rated VCL? I've had one last week. I think somebody was designing in a chlorine, a swimming pool environment. So it is really important to reach out and understand what type of VCL that you do need for the project. A vapor permeable membrane, they're opposite. They're installed on the external of the cold side of the structure, ultimately allowing the water vapor to escape from the inside of the building. The other good thing, like our wrap type, it stops water ingress during construction. I can think of a big project in Leeds where that's doing a grand job. The building's nice and dry inside under construction. Also stops wind from entering the building. Nice and dry throughout construction as well.
Super. Thank you, Nick.
Yeah.
Much appreciated. Sorry, I've got a bit of the cold today, so I'm struggling through here. Linda, Paul has asked, how does air movement differ from vapor diffusion in terms of moisture movement?
Well, so this is kind of there's two different ways of looking at it. So air movement is where the way moisture can enter a building. So if you like, so it's through infiltration or exfiltration. So this actually carries a lot of moisture through into the building. So you're talking about the holes, the gaps and the cracks, things like windows and doors. This is all going to get moisture into the building. And this is known as air infiltration. And it's also known as air transported moisture, depending on your terminology. Whereas vapor diffusion is not quite the same as air movement. It's basically referring to the diffusion of water molecules through material. So when you're looking at reducing vapor diffusion, or you would use something like vapor control layers, as Nick has just said there. And these were known as vapor barriers, if you like, but vapor control layers are terminology now, or VCL. So they don't completely stop vapor diffusion, they inhibit it by reducing the rate of water, that's the rate of water vapor movement across the material, if you like. But you've got to be looking at it carefully and how you manage it with these sort of buildings. But airtightness, I suppose, is often more considered more critical than vapor resistance these days. And because airtightness actually gives you a predominant pathway that moisture can actually transport through most wall assemblies. So if you're achieving airtightness, it helps protect the building, if you like, from moisture in the air, which can lead to interstitial condensation. It's one of those things, but you also have to properly manage it, if you like. So if you're thinking about air tightness and condensation, even 1 mil air gap in your insulation is enough to cause problems further down the line. So air tightness these days is also more important for energy efficiency. Well, vapor resistance is important. It's often secondary to air tightness to contain that continuous air barrier. Air tightness gives you that healthy and energy efficiency of the building that people are looking at now. So that air tightness strategy is more important, definitely in Scotland, than it has been in a long time.
Great answer. You're after Pam's job. think.
No.
I'm really technical, but
I'll
no,
let
I'm
Pam
kidding.
carry on with that. She's very good at it.
But I think you're right, Linda, and that's why we talk a lot at the Proctor Group around the balance of heat, air, and moisture movement when we're looking at these projects and trying to make sure that the products that we're offering is aligning with the strategy of that entire building. And I think Pam, often in technical, would be open to saying, look, this product isn't the best for that. Use a different one, and not necessarily ours. So it's important to look at the whole thing. Right, last few questions. So YouTube feed. Jamie from Sizewood here. Hello from Sizewood. We've met a couple of your people before. Good business. Often asked which membrane best complements a natural fibre insulation, such as under a suspended floor, which would best support in that application. Adam, you want to do that one?
Yeah, that is a good question actually, and we do get that quite a lot. So you could use, say, Proctor Air, an air permeable type membrane, but you'd then have to consider maybe your air tightness strategy elsewhere in the design. So more commonly, we see our airtight vapor permeable solutions as the ones that best complement it. Now, wrap tight would be good, but you'd have to consider how to adhere it, and in a suspended floor that could be quite challenging. So more commonly, maybe our Proctor Wrap or even Frame Pro solutions are probably the ones that best complement that design.
Okay, good. Agree. Pam, did you have something to add to that? No?
No,
We're looking
exactly
down.
that. I mean, we used to supply, a product for insulation support, but yeah, Adam's right. Proctor Wrap is definitely easy to work with. Well, draped to support the insulation or can be battened to the underside. So yeah, definitely Proctor Wrap.
Okay, good. And one in from Jackie. How often are we seeing requests for roofing modeling? Like, what's the frequency that we're getting in our Adam looks like he's going to answer, or one of you.
I could talk maybe commercial, Pam could talk the technical side of things. Do you want to go first, Pam?
Super. Yeah,
No, I
great.
was going to say, yeah, I mean, we do get inquiries, obviously, into technical. Um, we do roofies, we don't do it as a consultancy, so I think that's kind of important to say. We're not here to tell you what to use or where. Unfortunately, we're not geared up to be able to do that for other products. We don't want to comment on that. There are companies out there that do a commercial consultancy. Um, However, we are here to support your specification with our products. BS 5250 is quite sort of clearly defined recommendations for different wall types that should be assessed either by the standard glazier or by the roofie calculations. So we quite often get asked to do roofies, but actually it's not the right assessment for that particular build-up. So like SFS and timber frame, etc., they're actually quite stable because there's not a lot of inbuilt moisture, there's not a lot of moisture storage within those elements. Um, Therefore, things like glazier methods are usually absolutely perfect to model, and they're quick, they're easy, we can do a rapid response with that. Roofie analysis is a lot more in depth. Doesn't take that much longer to run the calculation, but it takes a lot longer to review and analyze and report on the results. So we do that a lot to support solid wall construction, which especially with IWI internal wall insulation, like our space there, that can be very critical. So it's kind of like a point where really beyond that, where it's highly insulated, you should be looking at roofing analysis. I mean, Linda touched on that earlier on with one of her questions. So we do quite a lot, and we're probably doing more side calculations now, I would actually say. But there's still a place for us to carry out roofing analysis to help support your projects and specifying our products.
Yeah, and I'd probably say that's the same in the commercial market. The solid wall constructions, the retrofit, the team get a lot of requests for woofy calcs, and rightfully so. I think that's referenced as a standard within the BS 5250 for solid wall as well. But we do get a lot of requests in the facade and modular sectors, just because of the added data. Although you might get the same result kind of in the glazer, the added data is a lot more reassuring to clients and architects on projects. So they do do like to play with it. There's then also loads of variations. So we take St. Sidwell's Point that we worked on, the amount of calculations and variations to understand the internal environments and the pool humidity areas and the gymnasium areas. So it can be a lot of work on our technical department as well, but good calculations.
Yeah, they are good, and we have used them for timber frame designers and modular people to look at what happens if the unit springs a leak or something happens to introduce a lot of moisture in there. How long does that additional moisture take to dry out? So, it can be a very, very strong tool used in the correct way.
Especially during times during COVID, when we had a lot of buildings exposed for longer than planned, sheathing boards got drenched, and then when things got resumed, they were putting the membrane and the insulation on quickly after, but there was a lot of moisture in that substrate. So it was good to analyze what happens because we could introduce that moisture. So that's quite interesting.
Good. And just lastly, it's not actually a question, and I think maybe someone's already answered it on the feed. So someone is working on their home in Lisbon, I think, adding a floor. Of course, you can get in touch with us next week. It sounds like a really interesting project. We love kind of international house builds. We've done some really cool stuff, supplied products to sort of apartments in Paris and one-off houses in different places. So yeah, we'd really be interested to hear more about that. Okay, so I've come to the end of the questions. I hope I haven't missed any. If I have, I apologize. We'll get back to you, but I think I've managed to get them all there. So thank you very much to the panel. I always say this, I know it's not easy just answering the questions kind of on the hop, so it is appreciated. And of course, without people coming to watch our live webinars, we wouldn't be answering any questions. So mainly to the audience, thank you for attending. You will receive a follow-up email after this, which has a link to the replay and a short survey. I do read every comment, and for example, in our last webinar, it said, could Keira do the when the webinar, what's the thing I'm looking for? The speaking over the
Voiceover.
the voiceover, thank you. Could she speak a bit slower? So I tried really hard to pay attention to that, and we did speak a little bit slower on the voiceover. Because of course I know what I'm talking about, but so yeah, I'm trying to say we do read and listen to the comments. So please feel free to keep sending them through constructively. We do value the feedback. Personalized CPD certification for today's webinar is available at the link I spoke about earlier, so proctorgroup.com/webinar, and you can get information on there. You can book a meeting with one of our team, the technical team, or face to face, someone like Nick or Linda out on the road. And so we're available to do that. And there's also areas now on our website you can upload your drawings, we can do different calcs, you can do your own U-value calcs with software that we've developed. So there's lots of options to play about with from a technical side if you'd like to. It really helps us if you give us a thumbs up if you enjoyed today's webinar, and you can also subscribe to our channel, which is available at the same link. Now, we do have a date for the next webinar if we want to put it in our diaries now. Does anyone have that off the top of their head? I forgot to write it down. I feel like
it is the
sorry.
Last weekend.
1st of May. I have here. So the 1st of May at 10 a.m. Not 100% sure what the topic will be yet, but please pop it in your diaries now so that you can join us then. Thank you very much for attending. Wishing you all a lovely weekend. Anything we can help with, please do just touch base, and we'll speak to you soon. Thank you.